Somewhere in a factory in Texas, a robot arm stops moving. Somewhere in a shipyard in Virginia, a welder puts down his torch and waits. Somewhere in a data center in Nevada, a cooling system hums, powered by a motor that depends on a metal most Americans have never heard of. None of these people are thinking about geopolitics. They are thinking about deadlines, paychecks, and the machines in front of them. But all three of them are standing on the front line of a war that has nothing to do with soldiers, and everything to do with the periodic table. This is not a war over tariffs. It is not a war over treasury bonds or semiconductors or even oil. It is a war over 17 strange, obscure elements buried inside almost every piece of advanced technology on Earth. They are called rare earths, and for the last 2 years they have quietly become the single most dangerous flashpoint between the United States and China. Treasury Secretary Scott Bessent has said it plainly and repeatedly. America's dependence on foreign critical minerals is a strategic vulnerability, one of the biggest the country faces. In January 2026, Bessent did something almost unheard of for a Treasury Secretary. He convened an emergency meeting of finance ministers, not from one or two countries, but from the G7, the European Union, Australia, India, South Korea, and Mexico, a coalition representing roughly 60% of global demand for critical minerals. His message to them was blunt. Urgency is the theme of the day, he told them, because the world has been moving far too slowly for far too long. Just months later, in July 2026, Bessent and U.S. Trade Representative Jameson Greer sat across the table from Chinese Vice Premier He Lifeng, pressing Beijing to honor its commitments on rare earths and agricultural purchases. To understand why one man is losing sleep over a handful of gray metallic elements, you have to go back 50 years to October 1973, when Arab oil producers announced an embargo against the United States. Almost overnight, the most powerful economy on the planet was brought to its knees by something as simple as a barrel of crude. Lines stretched around gas stations, prices tripled, and a generation of American policymakers learned a lesson they never forgot. Dependence on a single foreign supplier for something your entire economy runs on is not just risky. It is a weapon pointed at your own head. Now imagine that same vulnerability, except instead of oil, it is the material inside every fighter jet, every electric vehicle motor, every wind turbine, every missile guidance system, every smartphone, and every AI data center on the planet. That is rare earths in 2026. China controls somewhere between 80 and 90% of the world's rare earth processing capacity. Not mining, processing, the far more difficult, capital-intensive, environmentally brutal middle step where raw ore becomes usable material. You can dig rare earth ore out of the ground almost anywhere. The United States, Australia, even parts of Africa have significant deposits. But almost nowhere outside China can you turn that ore into the refined oxides, metals, and magnets that a fighter jet or an electric motor actually needs. That processing bottleneck is the choke point, and Beijing knows it. The story really accelerated in April 2025, when China launched a strict new licensing regime targeting 7 rare earth elements, aimed squarely at sectors feeding the American defense industry and other advanced technology sectors. Automakers around the world felt it almost immediately. Some were forced to pause production lines because they could not get the magnets they needed. Under intense pressure from Washington, Beijing eased some of those restrictions in July 2025. But the reprieve did not last. In October 2025, China expanded its export controls even further, adding new licensing requirements and, in a move that alarmed trade lawyers worldwide, introducing extraterritorial provisions that could, in theory, let Beijing regulate how controlled Chinese origin materials are used, even after they leave Chinese soil, even by companies that have never set foot in China. The world braced for a full-blown trade war. Then, on October 30th, 2025, at Gimhae International Airport on the sidelines of the APEC summit in Busan, South Korea, Presidents Trump and Xi Jinping sat down together for the first time since 2019. After nearly 2 hours of talks, they announced a truce. China agreed to suspend for 1 year the sweeping October export controls that had threatened to choke off the flow of rare earths to the rest of the world. The United States, in turn, agreed to postpone a set of planned export control expansions and cut certain tariffs. Trump called it an amazing meeting and told reporters aboard Air Force One that all the rare earths has been settled and that is for the world, adding that the arrangement was a 1-year deal that would be, in his words, very routinely extended as time goes by. Analysts were far more cautious. Piper Sandler strategists told clients bluntly that Xi was ready for Trump in his second term and has a powerful weapon in rare earths, arguing that China was getting the better end of the negotiation. The former U.S. Ambassador Nicholas Burns called it an uneasy truce in a long, still simmering trade war. Brookings scholars described the result as more commotion than motion, noting that Beijing had adeptly agreed only to a 1-year pause in the expansion of its export control regime, not a rollback, not a resolution, just a pause. And that pause turned out to be exactly what the skeptics warned it would be: temporary. By January 2026, just weeks after Bessent's emergency finance ministers meeting, China imposed tough new export controls on dual-use rare earth items headed to Japan, a clear signal that Beijing was willing to use the tool selectively, country by country, even while the broader U.S. truce technically remained in effect. Then came June 22, 2026. China's Ministry of Commerce placed 10 U.S. companies under new export restrictions, targeting dual-use items, including rare earth elements and related magnets. Among the companies named were MP Materials and USA Rare Earth, the two flagship companies at the center of Washington's entire strategy to build a rare earth supply chain independent of China. It was not a subtle move. Beijing was targeting the exact companies America was counting on to escape Chinese dependence, and doing it using the exact leverage that dependence still gave them. 2 days later, MOFCOM published a new rule effective July 1st, 2026, formalizing a public reporting and reward mechanism for anyone who flags suspected violations of strategic mineral export controls, a shift from a pure licensing system toward a full enforcement regime with built-in incentives to snitch on non-compliant companies. Then, on July 24th, 2026, the pressure spread to Europe, as China blocked shipments of dual-use materials to 14 firms across the European Union. Enforcement got personal, too. Japanese officials confirmed that 2 Japanese nationals employed by a major company were detained in Dalian, China, in May 2026 on allegations of smuggling goods subject to export restrictions, reportedly involving rare earth-related items, one of the first known cases of foreign nationals being detained inside China over an alleged rare earth export violation. And in the middle of all this, on July 16, 2026, the International Energy Agency dropped a number that made headlines everywhere. If China fully implements its rare earth export controls, the IEA warned, it could put $6.5 trillion of downstream manufacturing outside China at risk every single year. Automotive production alone faces more than $3 trillion of direct exposure. The United States and Europe together would absorb nearly half of that potential economic damage. IEA Executive Director Fadi Birol put it simply: vast amounts of economic value depend on relatively small volumes of critical minerals, whose supply chains remain highly concentrated and therefore vulnerable. Think about that for a second. A mineral that might cost a few dollars per kilogram, sitting inside a fighter jet worth $100 million, inside a car worth $40,000, inside a server rack worth $500,000. Pull that one small component out, and the whole machine stops. That is the entire logic of this war. You do not need to control the biggest, most expensive parts of a supply chain to hold it hostage. You just need to control the smallest, most irreplaceable ones. Rare earths are not the only front either. Gallium, germanium, and antimony, 3 obscure materials essential for high-frequency semiconductors, fiber optics, infrared sensors, and advanced chips, have been fighting their own parallel war since July 2023, when China first required licenses to export them. By December 2024, Beijing escalated to an outright ban on shipments of gallium, germanium, antimony, and graphite to the United States, a direct response to Washington's restrictions on advanced AI chip exports to China. That ban was eventually suspended as part of the broader Trump-Xi de-escalation, running until November 27, 2026, but the licensing regime never went away, and the ban on shipments to U.S. military end users never went away either. Beijing retains the ability to flip the switch back at any moment. So now picture the position American planners are actually in. The Pentagon has set a hard deadline, January 1st, 2027, under federal regulations, requiring defense contractors and manufacturers to stop purchasing rare earths, magnets, tungsten, molybdenum, and tantalum from China, Russia, Iran, or North Korea. It sounds decisive. It sounds like independence. But Reuters reported in July 2026 that this goal is colliding head-on with a stark, uncomfortable reality. American miners and processors simply are not ready. The Trump administration has poured tens of billions of dollars into nearly 150 different minerals companies trying to loosen China's grip. And yet, 5 months before the deadline, industry executives were warning that the timeline is extremely challenging, to put it mildly. Pat Ryan, CEO of U.S Rare Metals, a company that had originally planned to start refining by 2025, told Reuters his firm reworked its plans due to shifting Pentagon requirements, and now will not begin some production until 2027 at the earliest. Can the entire supply chain be propped up by 2027, he asked. Boy, I tell you, that's a battle. The United States actually has substantial reserves of most critical minerals sitting in the ground. What it lacks is the capacity to mine and process them at scale, the refineries, the separation facilities, the trained workforce, the environmental permits, all the unglamorous industrial infrastructure that China spent decades building while the West offshored it away. Firms have not produced tungsten domestically since 2015. Tantalum has not been mined in the U.S. since 1959. In February 2026, the Trump administration quietly launched something called Project Vault, a $12 billion effort to stockpile critical minerals for American manufacturers. And in a detail that captures the entire contradiction of this moment, officials acknowledged in April 2026 that in order to build the stockpile fast enough, they would need to initially buy minerals from anywhere in the world, including, awkwardly, from China itself. Lockheed Martin's CEO has publicly said his company handed the Department of Defense a wish list of minerals it wants stockpiled. Renewed fighting involving Iran has already begun eating into America's existing stockpiles of advanced missile interceptors, Patriots, and THAADs, according to defense analysts, adding real-world urgency to a problem that used to feel theoretical. So while Washington scrambles against its own deadline, what does the actual build-out look like on the ground? It starts with MP Materials, the only operational rare earth mining company in America, and the owner of Mountain Pass in California, the largest rare earth mining site in the Western Hemisphere, responsible for more than 10% of global supply on its own. In July 2025, the Pentagon did something no one expected from a Republican administration built on free market orthodoxy. It bought a stake in a private company, $400 million in convertible preferred equity, priced at just over $30 a share, plus warrants that brought the Defense Department's total ownership to roughly 15%, making the U.S. government MP Materials' single largest shareholder. The deal came with a $150 million 12-year government loan to fund new heavy rare earth separation circuits at Mountain Pass, enabling domestic production of dysprosium, terbium, and samarium, materials critical to next-generation military and aerospace systems. And then came the part that really changed the economics of the entire industry: a 10-year price floor, guaranteeing MP a minimum of $110 per kilogram for the neodymium praseodymium oxide it produces, no matter what happens to the global market price, no matter how low China tries to push prices to undercut Western producers. At the time the deal was struck, the market price inside China for the same material was under $60 per kilogram, meaning the U. Hess government was effectively subsidizing nearly double the market rate just to keep a domestic alternative alive and investable. MP's stock rallied 50% in a single day on the news. In February 2026, the Pentagon followed up with another $550 million, specifically to expand heavy rare earth separation capacity. By mid-2026, MP had also secured commitment letters from J.P. Morgan Chase and Goldman Sachs for up to $1 billion in construction financing for a new magnet manufacturing facility, and struck a $500 million partnership with Apple to supply magnets made in part from recycled feedstock at a facility in Fort Worth, Texas, nicknamed Independence. It gets more dramatic still. Because MP had agreed, as part of its deal with the Pentagon, to stop shipping its mined output to China, and because that output had previously supplied somewhere between 7 and 9% of China's own NdPr oxide production over the prior 3 years, the cutoff coincided with tightening supply inside China itself, driven partly by lower domestic mining and smelting quotas that Beijing never publicly explained. Rare earth prices actually surged above the $110 price floor the Pentagon had guaranteed MP, meaning the government's insurance policy briefly became almost unnecessary, a sign of just how tight and reactive this market has become. MP was not the only company getting massive government backing. In January 2026, the government awarded a landmark $1.6 billion funding package to USA Rare Earth, a rival firm racing to build its own mine-to-magnet supply chain. The competition between these two companies got so intense that in May 2026, MP Materials filed a lawsuit accusing USA Rare Earth of technology theft, a dispute that struck at the heart of the entire onshoring strategy, since both companies are considered essential to America's plan, and the legal fight now threatens project delays, investor confidence, and the very resilience the government spent billions trying to build. Beyond the two rare earth giants, money is flowing everywhere across the supply chain. The Export-Import Bank issued a letter of interest for a $120 million investment in critical metals. Corp's rare earth project in Greenland, the Department of Defense awarded $18.4 million to Ucore Rare Metals for a processing complex in Louisiana. Phoenix Tailings, a Massachusetts-based minerals startup, received a $500 million loan from the Department of Defense to build out its own capacity. Critical Metals Corp. Signed a 15-year offtake agreement tied to concentrate production from the Tanbreeze Rare Earth Project in Greenland, one of the largest known heavy rare earth deposits on the planet. None of this is happening in isolation. Washington understands it cannot solve this problem alone, and has spent the last year building a genuine coalition. In late October 2025, on the same Asia trip that produced the Busan Truce with Xi, Trump signed formal bilateral minerals frameworks with Australia and Japan, and memoranda of understanding with Malaysia and Thailand. Those frameworks established a rapid response mechanism led by the Secretary of Energy alongside counterparts in Japan and Australia to identify priority minerals and supply vulnerabilities in real time, and committed the countries to jointly invest in recycling technologies and to map mineral resources within their own territories. South Korea followed with its own fact sheet, committing up to $200 billion or $20 billion a year in investment flowing into the United States, alongside a commitment to stabilize and diversify critical mineral supply chains through public-private collaboration in mining and refining. Japan's experience is instructive here, because Japan has already lived through this exact nightmare once before, back in 2010, when China cut off rare earth exports during a diplomatic dispute. Through a combination of substitution, recycling, and strategic overseas investment representing $1.2 billion in government support, Japan managed to cut its reliance on Chinese rare earth elements and magnets from 90% down to 60% within just 2 years. That track record is exactly why Japan's rare earth recycling program, known as urban mining, is now one of the most advanced in the world, backed by roughly $238 million in fiscal year 2026 government funding, involving giants like Daikin Industries, Shin-Etsu Chemical, and Hitachi, and achieving recovery rates as high as 96% for neodymium and 91% for dysprosium using new selective extraction technology developed at Kyoto University. The coalition building did not stop with bilateral deals. In May 2026, the United States, Australia, India, and Japan, the Quad nations, announced a formal critical minerals initiative framework at their foreign ministers' meeting in New Delhi, aimed specifically at diversifying and securing rare earth supply chains among the 4 countries. In February 2026, at a critical minerals ministerial hosted by Secretary of State Marco Rubio, alongside Vice President Vance, Secretary Bessent, and other top officials, representatives from 54 countries and the European Commission gathered in Washington, and Rubio announced the creation of a new body called FORGE, the successor to the previous Mineral Security Partnership, to be chaired first by South Korea, explicitly designed to move with, in Rubio's words, bold and decisive action. A private sector initiative called Pax Silica was launched alongside it, aimed at mobilizing investment across mining, refining, end-use applications, and recycling. Individual deals within that broader push read like a shopping list of quiet industrial rearmament. In August 2025, Korea Zinc, operator of the world's largest zinc smelter, signed an agreement with Lockheed Martin to supply refined germanium for advanced semiconductor production and committed more than $100 million to build a new recovery facility in Ulsan, South Korea. The U.S. International Development Finance Corporation has quietly invested more than $1 billion across new mineral exploration deals worldwide, including a $75 million seed investment in critical minerals and strategic sectors inside Ukraine, which has since mobilized another $75 million in non-U.S. funding and $600 million into something called the Orion Critical Minerals Consortium, which has pulled in an additional $1.2 billion in outside investment. And recycling, once an afterthought, has become a serious pillar of the strategy in its own right. Less than 5% of rare earth magnets are currently recovered globally, with most of the neodymium, praseodymium, dysprosium, and terbium content simply lost, shredded into undifferentiated e-waste, or melted anonymously into scrap steel. That is starting to change fast. In January 2026, the UK opened Hypromag's facility in Birmingham, Britain's first commercial rare earth magnet, recycling and manufacturing plant in 25 years, using a patented hydrogen processing technology developed at the University of Birmingham that strips NdFeB magnets out of end-of-life products and reprocesses them into new magnet-grade alloy with a fraction of the carbon footprint of virgin mining. The European Union's Critical Raw Materials Act now legally requires 25% of the bloc's strategic raw material consumption to come from recycling by 2030, a mandate already triggering major investment and faster permitting for recycling projects across the continent. Advances in green chemistry, including bioleaching, molten salt electrolysis, and advanced magnet-based separation, are moving rapidly from pilot programs toward genuine industrial scale, aiming to finally make rare earth recycling commercially competitive with mining raw ore out of the ground. So step back and look at the whole board. On one side, China, with roughly 80 to 90% of global rare earth processing capacity, a dominant grip on gallium and germanium for advanced semiconductors, and a demonstrated willingness to weaponize export licenses against individual countries, individual companies, and even individual foreign nationals. On the other side, a coalition of the United States and its allies, throwing tens of billions of dollars at mines, refineries, magnet factories, recycling plants, and strategic stockpiles, all racing against a self-imposed deadline that even the people building it privately admit they may not hit. In between, sitting exposed in the crossfire, are the actual companies that make the modern world run: automakers, defense contractors, semiconductor firms, and AI infrastructure builders, all of whom now have to treat a handful of gray metallic elements with the same seriousness they once reserved for crude oil. The Semiconductor Industry Association made this explicit in its own 2026 filings to the U.S. Trade Representative, laying out in granular detail how gallium underpins the chips used in radar and wireless communications, how germanium underpins specialized silicon germanium chips, and how rare earths run through everything from chip-making equipment itself to the servers and networking hardware that power AI data centers. This is why the story is so much bigger than magnets and electric cars. It touches artificial intelligence because the data centers training the next generation of AI models depend on components built with these exact materials. It touches national defense because F-35 fighter jets, submarines, and precision-guided missiles are saturated with rare earth magnets that have no easy substitute. It touches the energy transition because electric vehicle motors and wind turbines are two of the largest single sources of rare earth demand on the planet. It touches basic manufacturing because the IEA's own numbers show automotive production alone carries more than $3 trillion of direct exposure if the Chinese processing spigot gets shut off. And it touches ordinary consumer electronics because the smartphone sitting in your pocket right now likely contains rare earth magnets sourced at some point in its supply chain from a facility inside China. There is also real risk sitting on China's side of the table, and it is worth being honest about that. Every time Beijing tightens the screws, it hands Washington and its allies one more politically unstoppable reason to keep funding alternatives that would otherwise have been considered too expensive, too slow, or too uneconomical to build. Price floors that looked like reckless government intervention in mid-2025 look, by mid-2026, like the only reason a Western rare earth industry exists at all. Every export restriction accelerates the very decoupling China is trying to prevent, because it proves to nervous CEOs and defense planners exactly why they cannot afford to depend on a single supplier ever again. That is the trap sitting underneath this entire conflict. The more effectively China uses its leverage today, the less leverage it is likely to have 5 or 10 years from now, once mines, refineries, and recycling plants currently under construction in California, Texas, South Carolina, Louisiana, Australia, Japan, and Greenland finally come fully online. But 5 or 10 years is a long time, and right now, today, the United States remains deeply, uncomfortably dependent. The gap between the ambition of January 1st, 2027 and the reality on the ground is not a rounding error. It is measured in years of construction, permitting, and workforce training that simply cannot be compressed no matter how much money gets thrown at the problem. For investors, this entire saga has created a genuinely new category of opportunity and a genuinely new category of risk almost overnight. Companies building American mines, refineries, and magnet plants are receiving government support on a scale that would have been unthinkable in prior administrations, from direct equity stakes and price floors to multi-hundred-million-dollar loans and offtake guarantees. Recycling technology, once a niche sustainability story, is now a strategic pillar with real government mandates behind it in both the United States and Europe. Alternative material research, including non-rare earth magnet chemistries using iron, nitrogen, or manganese compounds, is attracting serious funding, even though most experts agree those alternatives remain years away from matching the performance of traditional neodymium magnets at scale. Meanwhile, manufacturers still heavily dependent on Chinese-sourced rare earths face real exposure to sudden cost spikes, export delays, and the kind of geopolitical whiplash that has already forced automakers to pause production lines once already. The mineral premium? The extra cost buyers now willingly pay for assured non-Chinese supply over long time frames has become a real and growing line item in corporate procurement decisions, not a theoretical concept in a think tank report. There's a quieter irony sitting inside all of this that almost never makes the headlines. China's own domestic rare earth mining and smelting quotas have been trending lower, not higher, even as global demand keeps climbing, and analysts widely believe those tighter quotas, never publicly explained by Beijing, are one reason prices firmed up even before the latest round of export restrictions hit. A country that built its entire geopolitical leverage on cheap, abundant rare earth supply is now quietly managing its own resource base more carefully, aware that decades of underpriced extraction have real environmental and long-term supply costs of their own. That is not weakness exactly, but it is a reminder that even the dominant player in this market is not operating from a position of unlimited, effortless abundance. Meanwhile, back in Washington, The political mechanics behind all this spending are worth understanding too, because none of it happened by accident. The Defense Production Act, a Korean War-era law that lets the federal government direct private industry toward national security priorities, has become the primary legal vehicle for almost every one of these deals, from the MP Materials equity stake to the loans flowing to Ucore and Phoenix tailings. Authorization under that act was set to expire on September 30th, 2025, and its renewal became its own quiet flashpoint in Washington. A reminder that even the legal scaffolding underneath America's critical mineral strategy has to be actively maintained year after year by Congress. Defense contractors are not waiting passively for the government to solve this either. Lockheed Martin's own list of minerals it once stockpiled reflects a broader trend across the defense industrial base, where prime contractors are now pushing suppliers to document, line by line, exactly which components in a missile, a radar system, or an aircraft depend on Chinese origin materials, a process that sounds simple but has turned into a genuinely massive undertaking given how deeply embedded these materials are in decades-old supply chains. Congress has taken notice as well. Senator Maria Cantwell chaired a Senate Energy Subcommittee hearing dedicated entirely to the problem, declaring bluntly that America can no longer afford to ignore China's monopoly on rare earth minerals and other strategic metals, a monopoly she and her colleagues argue threatens to constrict both technological advancement and basic economic growth if left unaddressed. That bipartisan alarm is part of why funding for this effort has kept flowing, even as other priorities in Washington have fought over shrinking budgets. It is also why compliance lawyers, an unglamorous but suddenly very in-demand profession, have become essential reading for any company touching these supply chains, since Beijing's new reporting and reward mechanism means a single misclassified shipment can now trigger real enforcement risk, not just paperwork. Companies are being advised to map every Chinese origin input in their products, document supplier declarations in detail, and classify materials under both U.S. and Chinese control lists simultaneously, a level of bureaucratic precision that simply did not exist in global manufacturing 5 years ago. None of this is temporary friction that resolves itself once a truce gets renewed. It is becoming a permanent feature of how advanced manufacturing works, the same way sanctions compliance became a permanent feature of international banking after the 2000s. So where does this actually end? The honest answer is that nobody fully knows, not the Pentagon, not the Treasury, not the analysts at the IEA, and certainly not the traders pricing rare earth futures contracts day to day. What is clear is that the United States does not need to produce every single mineral domestically to be safe. It needs enough diversified, reliable, redundant sources across enough countries that no single foreign government, however powerful, can hold the entire advanced manufacturing base of the free world hostage with a single ministry announcement. That is the real goal hiding behind all the mine openings, the government equity stakes, the price floors, the bilateral frameworks, and the recycling mandates. Not total self-sufficiency, which is probably impossible, but resilience, redundancy, and enough leverage of its own that the next crisis does not turn into a full-blown embargo. The real question, the one that actually matters for anyone watching this unfold, is whether America and its allies can finish building that resilience before the next major confrontation with Beijing, rather than scrambling to build it in the middle of one, the way they scrambled in April 2025, and again in June 2026, and will very likely scramble again before this decade is over. Because in the next major clash between the United States and China, the most consequential weapon on the table almost certainly will not be a tariff, and it almost certainly will not be a warship. It will be a mineral you cannot pronounce, weighing only a few grams, sitting quietly inside a machine worth millions of dollars, waiting for someone, somewhere, to decide whether it gets to cross a border.